What we're going to do with this unit, and I mean, we've been kind of doing it with the last two units, is we're going to talk about the relationships between sets of information, okay? Which is a very important part, like, of everyday life. We talk about the relationship between sets of information all the time. Like, could be your age and what your income is, or it could be time and how far you've driven, or how far you've flown. There's always some kind of, there's two pieces of information and there can be some relationship between them. And we want to be able to describe those mathematically, because from those relationships, we can make predictions, okay? I mean, all the graphing we do, and we've done pretty simple graphing to this point. We've just been graphing lines, okay? And, but the next couple years, we're going to be graphing a lot more different shapes that can represent different real life relationships, okay? So graphing is really important in mathematics because it allows us to show something visually, and it also allows us to make some predictions. I mean, you know, what do you think financial advisors did, right? Did they just sort of say, oh, well, maybe that stock has a nice name, so why don't you try investing in that one? Yeah, it doesn't quite work that way, okay? They study mathematical models to see what's a pattern, and they make predictions from that, and they say, well, it looks like this may go up, so you may want to invest in this, okay? So they use mathematics all the time. But we're going to keep it pretty simple to start. So before we sort of get into it, we got to know some terms. These three terms. A set, okay? A set is a collection of information. It could be a collection of numbers, maybe the ages of all the students in BH, or the ages of all the students in Winnipeg, or the income of all the adults in River Heights. It doesn't have to be numbers, could be names, okay? Could be the last name. I mean, like when you do well, not so much anymore, but when they came out with paper phone books, it was a collection of information, people's names. Element of a set is one piece of information in that set. So if you've got a collection of ages of people, one of the pieces of information, one of the elements could be 45 years old, if we're talking about all the adults in Winnipeg. Although I'm sure there'd be several that would be 45. And a relation is some rule that relates one piece of one set to another set. That it relates one set to another. So like I said, you could have a set of information could contain times, like 20 minutes, 25 minutes, 33 minutes. And then another set could contain distances. And then maybe there's some rule that depending on the time, this is how far you travel. Okay. So there's different ways that we can show relationships, and we've seen some of these already. Okay? I mean, a big one is graphs. But we just we didn't really go into real life problems. We just kind of did an XY coordinate grid. Okay? But we're going to go into more sort of real life situations, although I hesitate to say that this one is. So we got two sets of information. We got one that contains the letters A, B, C, and D. And we got one that contains the words act, cause, and tell. There's different ways we could show a relation between these two sets of information. One would be a set of ordered pairs. So let's say the rule is we are relating a letter to a word that letter appears in. So one set of ordered pairs, or one pair would be A. What letter does that appear in? Act. That would be one ordered pair. We could do another ordered pairing of A because there's another word. Which one? Tap. And then we could do that for all the letters. B appears in tap, and that's it. C appears in what? Act and caught. And finally, D appears in caught. And then what we do with all of these pairs to show that we're keeping them together, we put braces. So if the rule of this relationship between these two sets of information is we're relating the letters in the first set to the words that they appear in the second set, this would be the sort of set of ordered pairs that would describe that relation. Okay? We should do a table. So we got the first, and it would be very similar to what we just did. So we would have letter and the words that letter appears. So we would just write these vertically. So it would be A, act, A, tab, B, tab, C, act, C, caught, and D, caught. We could do something called, and you haven't, I don't think you've seen this before, an arrow diagram. To show the relationship between the first set of information, the letters, and the second set of information, the words that they appear in. So here's how we do an arrow diagram, is we do two ovals. And we write all the elements of the first set in the first oval, so A, B, C, D. And we write all the elements of the second set into the second oval, which are the words, act, tab, caught. And I show the relationship by a series of arrows. A appears in act, so I'm going to connect those. A also appears in tab, so I'm going to draw another arrow from A. Relax, ladies. B appears in tab. C appears in act, and C appears in caught. And D appears in caught. So it's a little bit convoluted. It's kind of it's a little bit of a messy way to show the relation. But these all show the same thing, these three. Okay? And then another way, or other ways that we could show it, and I'm not going to write them, would be a graph. And we'll see that in a couple of examples we do. But this would have to be a special type of graph that we use when there's no numbers. It would be like a bar graph. We could use words to describe it. So to describe the relation, it would be the letters in the first set of information relates to the words that they appear in the second set of information. And once we start getting numbers, which we can't do here, we can't write an equation. We can do equations. That's sort of where we want to get to. So all we really want to talk about today is just sort of what this thing means and the different ways you can show it. So let's look at a couple of examples. We've got two sets of information, therefore a relation, relating a community in Canada with a northern territory that that community is located in. So that would be the rule. We're relating the community to the territory it's in. And it's shown to you as a table. So how would we take this and convert it to a set of ordered pairs? Well, we would just take each pair and write them out. And we'll use shorthand just to save ourselves a little time. So we would have a river is in the Northwest Territories. That's one part of it. That's one part of the relation. Iqaluit just put none in front of it. Nanacinnic again is Nunavut. Old Crow is Yukon. White Horse is Yukon. And Yellowknife bear. Is Northwest Territories. I would show that using an arrow diagram. I'll do it over here because I've kind of room on that side. So I would have Hay River, Iqaluit. I'm going to use Nanacinnic, Crow, White Horse, and Yellowknife. I would have all there. Now notice in the second set of information, some of the elements appear more than once. You don't have to write them twice. Like Northwest Territories appears twice, only write it once. Same with Nunavut, and same with Yukon. So let's connect. Hay River, Northwest Territories. Iqaluit is Nunavut. So is Nanacinnic. So I draw an arrow there. Old Crow is Yukon. So is White Horse. But Yellowknife, I've got to draw an arrow back up to Northwest Territories. Okay. Second example, here we have a different relation relating the breed of dog to its mean, and mean just means, if you take statistics, you'll learn this, average. So it's relating certain breeds of dogs, 6 of them, with their average height. So now we've introduced some numbers into one of the sets of information. Okay. So how do we do it as a table? Well, what would my titles be? What would the first column title be? 3. And what about the second? Or mean heights. So we write the dogs. We've got an Afghan, got a Chihuahua, Corgi, Golden Retriever, German Shepherd, and then these huge dogs, none of these. Well, in order to get their mean heights, I've got to be able to read this graph. So what's the mean height of an Afghan? 75. Chihuahua? 20. Corgi? 30. Retriever? Same with a German Shepherd. And a Malamute? 65. And then, as an arrow diagram, we need an oval that has all breeds, and an oval that contains all the average heights, and we don't have to write one more than once. Generally, I'll do the breeds first. So Afghan, Chihuahua, Corgi, Golden Retriever, Shepherd, and a Malamute. Now, when we have numbers, no, I'm going to leave it as is. So we'll write 75, 20, 30, 60. Don't write 60 again. 65. Just write all the different ones, because the arrows will take care of the relationship. So Afghan 75, Chihuahua 20, Corgi 30, Golden Retriever 60, same with a German Shepherd, Malamute 65. And then finally, we've got, it kind of looks like an arrow diagram, but we haven't written all the Western Canadian cities because there's just too many to write. And notice it's Western Canadian cities in both sets of information. But the rule is within 1 hour driving distance of another Canadian city. Okay? So describe the relation in words. So we would say Western Canadian cities within 1 hour driving distance of other Western Canadian cities. Obviously, we don't want to have like an ordered pair that has the same city listed in it. That really doesn't make any sense. But let's test your geography. Can you think of a city in Western Canada that is within 1 hour driving distance of another city? Think local. Think Manitoba. Winnipeg, what other city could we get to in an hour? Regina? No, that's 5 hours. Carmen? Yes. Brandon is 2 hours. Okay, we got some yeah, we're a little geo challenged. How about Selkirk? How about Portage? But Carmen works. Can you think of another one not in Manitoba? Any in Saskatchewan? Regina and no, that's more than no, that's you keep trying.
I don't know. I don't know if it was Moose Jaw.
Yes, whoever said that. I said Regina Moose Jaw. So, and before anybody asks, no, you're not going to see a test question like this. Okay.